Okay, we're asked to find the equation of the tangent line to the graph y is equal to the square root of x plus 1 over 2x plus 1 at x equals 1. So what we're going to do is and there's a couple ways we can do this. There's a formula in the book, okay? So on page 90, where this example comes from, there's a formula that says that the equation of the tangent line to the function y is equal to f of x at the point x sub naught comma f of x sub naught. Okay, I said that wrong. F of x sub naught. If this is your function and you're trying to find the tangent line, okay, then you can follow the formula. The tangent line I don't really like to use y again, okay, because it's really a different function here. So I'm just going to call it something else. I'm going to call it oh, I hate to call it t as well. Well, I guess let's just call it y, but just realize that this y and this y are different. Okay, this is equal to the function evaluated at the point times, plus the derivative of the function at the point, so the slope of the tangent line at that point, times delta x, the difference. Okay, so this is going to be, we can follow this. Okay, so but here's the big picture. We have 1. Okay, so let's say I'm just going to draw out, we don't even need to know what this guy looks like. Okay, I'm just going to draw out a generic curve. So let's say the curve bends something like that. So right here is x equals 1. Okay, and the height of the function is f at 1. Okay, so let's go ahead and plug that in so we can actually get an ordered pair. So this is 1 comma. Now to get this guy out, we're going to take 1 and plug it into here, so it'll be the square root of 1 plus 1 over 2 times 1 plus 1. So that'll be 1 plus 1 over 2 times 2, or that'll be 1 plus 1/4, which is the same thing as 5/4. Okay. So if you had this function y here, okay, that's the function y. If you plugged in 1, you would get out 5/4. Okay, so no big deal there. Now, the equation of the tangent line, okay, so I'll draw it in as blue. The tangent line is represented as the following. Well, first, the slope of it is given by the derivative of the function. So let's go ahead and take the derivative. So dy dx, derivative of this, is equal to d dx of the square root of x plus 1 over 2 x plus 1. Just like that. And so that is equal to d dx of the square root of x plus, now I can pull out the 1/2 if I want to, and I can write this as d dx of 1 over, I just write it like this, x plus 1, like that. Okay, so let's keep going. So d dx of x squared is 1 over 2 square roots of x. Okay, we've already been given that. So plus 1/2. Now the derivative of this, we can use the reciprocal rule, or we can use the quotient rule. So I'm going to use the quotient rule here. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom. And now the derivative of the bottom is just 1, because the derivative of x plus 1 is just 1. And then that whole guy is over the bottom squared. So this will be 1 over 2 square roots of x plus 1/2 times the quantity -1. So what I'm going to do is I'm just going to pull out that negative like that. So it'll be 1 over x plus 1 squared. And that is equal to 1 over 2 square roots of x minus 1 over 2 times x plus 1 squared. So that's our derivative. That's our dy dx. Now, why do we need that? This tells us the slope of this blue line. So what I need to do, okay, I've got dy dx, or f prime, is equal to, I'm going to erase all this over here on the right side so that I get some room. Okay, so I got that guy right there. And then what I'm going to do is I'm going to evaluate it at 1 because that'll tell me the slope of this line. So dy dx at 1 is equal to 1 over 2 times 1 minus 1 over 2 times 1 plus 1 squared. Okay, so that's 1/2 minus 1 over 2 times, now this is 2 squared, so that'll be 4. So this would be 1/2 minus 1/8. And if we get a common denominator here, we end up with positive 3/8. So the slope of this blue line is 3/8. So the m value is 3/8. Now let's go back here, and I'm going to get rid of all this because we don't need it anymore. Okay. And now if you think about, we don't need this either anymore. And we don't need any of this. Okay. If you think about what we've done so far, we want to find the equation. We're asked to find the equation of the tangent line, which is the blue line. What we've got is the slope and a point. So if we use the generic formula, y minus y1 is equal to m times x minus x1, then we get y minus, our y1 value is the only point on the blue line that we've got, which is 1, 5/4, so our y1 value will be 5/4. Our m value is the slope of the line, which is 3/8. Our x is our variable, and then our x1 value is this guy right here. It's the x value of the only point that we have on the blue line, like that. And so we can go ahead and move things around if we want to. So I'm gonna write this just a little bit better. So this will be, because I personally wanted it in slope-intercept form because I like it better that way. So this is good right here. This is fine. Okay, let me go just a little bit further. This will be y is equal to 3/8 x minus 3/8 plus 5/4. So y is equal to 3/8 x minus 3/8 plus 10/8. And so I'll get y is equal to 3/8 x plus, let's see here, the difference here is 7. So I'll get 7/8, just like that. Okay, hang on one second. Okay, what I want to do is I want to show you that we can verify using a graphing utility that that value is correct. So what I'm going to do is I'm just going to plug in the original function, which was the square root of x. So I'll say y equals. You don't actually have to put y equals. Desmos defaults to this. So y is equal to the square root of x plus 1 divided by the quantity, 2 times the quantity, x plus 1. Just like that. So this is our function over here. Okay. Now what we want, I'm going to zoom in a little bit here. what we want is the equation of the tangent line right at that point, right here. Okay, so basically we want this line. There's going to be a tangent line that runs in right through here. Now I should have found the equation with it with my answer. So let's go ahead and plug in our answer and see if that's actually tangent at that point. So the solution that I got was y is equal to, and let me go back here and just take a look at it. I had y is equal to 3/8 x plus 7/8. So let's go ahead and plug that in. So y is equal to 3/8 times x plus 7/8. And what I want you to notice is this blue line right here is tangent. At least it looks like it's tangent at the point where x is equal to 1. So where x is equal to 1, if I go up, it looks like this blue line is actually tangent to the red curve, which is what I'm looking for. I want to find the line that's tangent at the point x equals 1. And it looks like I found that. Another thing you can do is you can go to Wolfram Alpha and you can ask it to find, oops, so we'll ask it to find the tangent line to the equation square root of x plus 1 divided by the quantity 2 times x plus 1, like that, at x equals 1. And we'll see, sometimes it's pretty good at figuring out what you're trying to say here. Okay, and so if we look down here, it says tangent line 2, so this is what it's interpreting it as. Notice that it's got the graph right here for you. It shows the lines, it gives you a key, and it also gives you, it gives you the solution as well. So there's a lot of ways that you can go ahead and you can verify these problems in your homework.